Hi everyone, so let's do today's daily lead code challenge question. I just opened it and let's see. It is streaming, right? Yeah. Okay, so let's look at the problem. This is a daily lead code, right? Okay, yeah, it is. So I'll set a timer for 20 minutes. And let's see. 2461 maximum sum of distinct subarrays with length k. So you are given an integer array norms and an integer k. Find the maximum subarray sum of all the subarrays. I'm sorry, like I'm in the hall, so there is an attached kitchen there and some kitchen sound is coming here. Excuse me, please, can you turn off that sound? No. I'm recording. Okay. So anyway, let's see. Maximum sum of distinct subarrays with length k. You are given an integer array norms and integer k. Find the maximum subarray sum of all the subarrays of norms that meet the following conditions. I'm streaming, right? Okay, yeah. Given an integer array norms and an integer k, find the maximum subarray sum of all the subarrays of norms that meet the following conditions. The length of subarray is k, and why is every problem nowadays sliding into problem? The length of the subarray is k and all the elements of the subarray are distinct. Return the maximum subarray sum of all the subarrays that meet the conditions. If no subarray meets the condition, then return 0. A subarray is a contiguous non-empty sequence of elements within an array. Interesting. So I think what this problem is saying is I need to find the maximum sub of the subarray. So 154 is a subarray because k is equal to 3. 4542 is a subarray. 429 is a subarray. 299 is a subarray. 999 is not a subarray according to this one because all the elements should be distinct. Okay, so I need to find the maximum sum. I guess this is a sliding into problem, right? I can do it in O of n time, I think, because I can just go from 1 to 154. So this is the sum will be something, and 542 I will have some sum, right? So I will have some sum here, I will have one sum here, and I can just slide from one window to another window, and the sum of the window will be, so if I know the sum of this window, then sum of this window will just be previous sum minus this number plus new number, right? So that way I will just have the running sum of every subarray, and but another thing I should be careful is I should not as this one, all the elements are distinct. So how will I know if all the elements are distinct in a subarray? 154, 542, 429, 299. Yeah, that is a challenge, I think, because that is a challenge actually. Or what I can do is, I don't know, what can I do to make sure that, because if it is just 3 elements, then it is easy, right? But there might be so many elements. Suppose say this is the, suppose k is equal to this one, suppose this is a window, then in this case how can I be sure? Bisal, can you please turn off that fan? No, I cannot. Okay. So in this case, how will I know that this window has distinct? So suppose this is the previous window, okay? Suppose okay, so suppose this is the previous window. Suppose this is the previous window, and when I go to the next window, then how will I know that 3 is already inside this window? That is my question. So if I go here, it is easy that okay, I will do -8 and +3 and I will get the running sum, right? But how will I know that this is a all the sub elements of this array is distinct? What should I do? One solution is obviously to keep track of hash map. I guess in a hash map I can just keep track of all the elements. 8 1, like 1 will be it. Oh, not a hash map actually. I can just keep, because it will just be 1, so I can just keep track of set. So inside my set I will have to store all the numbers all the time. Okay, and once I move the window, I will have to delete it and then check if 3 exists here or not. If 3 is contained, then it means that I will have to discard this sum, and then I and j again. So I'll have to delete 2, delete 1, and then check if 10 exists here or not. Yeah, that is one. That is one, right? But this will give me O of n time complexity. I think this would work. Is there any other way? Is there any other way to check if all the elements of the subarray are distinct or not? No, I don't think so. Because without keeping track, will we know if that element already exists or not? We will not know. Okay, so I will just write a code here. Start coding here of n time complexity, because we are moving just one, because we are just going through each array just once only. So it is O of n times k, because we are moving through 1 2 3. Oh, actually it is just O of n, because we are going through each element only one time. It 1 2 and then 3 4 5, we are only going through one time. Yeah, and then O of n and O of n is space complexity. Okay, let's write the code. Yay! Pumped up, because I feel like, I hope that this is the solution, because sometimes we feel like, oh, this is so easy, wow, I got it, and at last when you click submit, you will see that you have missed, you see that so many test cases have failed and you have missed so many edge cases. So let's check. I hope that the edge cases, there are no any edge cases here. Yeah, I cannot wait. I'm very impatient. I don't want to test against any edge cases. I just want to go directly to coding. I'm very impatient person. So let's code. Yeah, ideally I should have looked for edge cases. Oh my god, such a big sound. It's a loud noise. I should have used my headphones, my AirPods. But anyway, so 10 minutes is already gone. So let's do it. I is equal to 0. I can say that this is the window start, or you can say sub array start point and sub array end point, and so this is start point and this is end point, right? Because if it is 3, then it will be 0 1 2. Oh, it should be k minus 1. Now I need to find the sum of the subarray. For I is equal to subarray start, I is less than subarray end, I plus plus. So for in the beginning I need to find the running sum. Running sum is equal to 0. Running sum plus is equal to nums I. So this will give me a running sum, initial sum from, suppose if this is the case, suppose if k is equal to 3, so it will give me initial sum from 8 to 1. Oh, actually what I should do is, you know what I should do, I should also keep track of let unique let unique sub array is equal to new set, and then I should also add to that set, and what is the answer? Let maximum, right? Maximum sum is equal to 0, and what I can do is, if this unique sub array set, in this case, if its size is equal to k, then it means that everything is unique, right? So I can just say that maximum sum will be equal to running sum in this case. But if it is not, then I cannot do. Okay, now let's start rolling the window. So we are done from I to j. Now we have to roll 8 1 2. We have to roll the window, right? So let's start rolling the window. So while we reach the end, right? So while Subarray sum it's less than norm start length. So while it is less than norm start length, then I will keep on continuing. So while it is less than norm start length minus 1, actually, because I do not want to, right? So if it has already reached here, less than or equal to, actually, or no, if it has already reached here, then why should I do that? So only if it is less than this one, I should continue doing it. So now I should continue. So I've already done one thing, and now I will calculate the running sum again. So my Subarray start will, so now move the window forward, so I will move the window forward unless it is here. So when I move the window forward, then what happens? Subarray start plus happens, and then Subarray end will go, right? But before moving window forward, what I can do is, I can just do running sum minus is equal to norms of Subarray start, and then after doing this, running sum will be, so if I was here, j was here, then I will move it here. So new j will be, I will be adding new j, Subarray end. Okay, so here I am deleting the previous Windows end, delete previous Windows end, and add current Windows end, right? So if it was 812, and if it was 1 2 3, and if I go to 2 3 4, then previous Windows start, actually I have to delete it. So here window forward, i.e. deleting previous Windows start, and then adding current Windows end. This is what shifting, or I can say shift forward by 1 point. So this is what it does. So running sum we calculate by looking at this, right? But we should look at now, we should see if this exists or not, actually. Yeah, if unique subarray dot set has this element or not. Actually, after doing this, I should after moving it, I should delete it. I should delete this number. I should delete this number, from unique subarray, and I'm adding current windows in. So I should check if unique subarray has this number or not. If unique subarray has this number, then if it does not have this number, then only if it does not have this number, it means that that the new subarray is it's unique. You know what? I just thought about one thing, and then maximum sum will be equal to math dot maximum of running sum comma maximum sum comma running sum. You know what I thought? I thought that this one it has a one edge case. But what if previous was also not also a duplicate one? What if it was like 2 2 2 and it was 3? So I and j, right? And then ij. So I will so my previous array will be just my set will just have content 2. So if I move 3 is not here. 3 is not here. It doesn't mean that it does not have distinct element. So this will not just by checking this, it does not guarantee that our new subarray is unique. So what I can do here is I can just add this new norms to subarray end, and then I can just check the size actually. So if its size if its size is equal to k, then maximum sum, okay, and then at last return what? Return maximum sum. Yeah, I think this should work. Yeah, I think this should work. Yeah, so we have only what we have done is two things. We are just shifting window by 1 point every time, and every time when we shift the window, we calculate the running sum. So running sum, when we shift the window, what happens when we shift the window? One element gets deleted, another element gets added, right? That's what we are doing here. To the running sum, we just delete one and add one. And also to make sure that all the elements of the subarray are distinct, we are just creating a set, and every time we are maintaining that set for every subarray. So actually the subarrays space complexity will be just O of k, because we are always deleting it, right? So the space, it will not exceed k. Yeah, that's what we are doing. So this would work, I think. Oh no, this didn't work. Unique subarray set is not defined. Dot size is not a function. Then what is a function? How to find length of set? Yes. My size. Oh, size is not a function. Size is just like this. Unique subarray. Oh. So takeaway is here. Don't define. This was my fear, and it got. Okay. Actually, what I should do is how did this happen? Like 154, 549, 542, 429, 299, 999. What happened? I don't understand what happened. How is output 0 here? So maximum sum is 0 and everything is 0, and the size is, if it is equal to k, that addition from 0 to, oh, it should be equal. So test cases has increased, that is great. So let's see, 3, 999, 991, 912, 9, 10, 11, 12. Yeah, 912 should be the answer. 1, 2, 3, 3, 4, 5, 6. So why 912 is not the answer here? So 999. 999, right? So in the beginning it should be 999, and it should shift 9. When it shifts, then it should be, oh yeah, 91. I think I get it. So that is also one edge cases. One edge case, I think. 991. So what happens is, my when it is 991, then my set will contain 91, right? So if I delete this 9, then it will just delete. It will just think that 9 is not. Yeah, I cannot delete from the set. Why did I not think about it? Yeah, this is not a hard problem, but there are this is the edge case that I did not think about, because I was in a hurry for coding, which I should not have done. But yeah, thanks this example. So yeah, so what can I do then? How to make sure that it is not distinct? So see, in this case, so this is 911. Okay, this is the first subarray, and when I shift the window, so in this subarray my number distinct element will be actually even in this one as so 991, right? So my set will contain 9, so I and j, and when I move from here to here, I will delete 9 and only keep 1. So should I, does this mean that I should maintain a hash map instead of set, so that I will not delete this, so that if I know that, okay, the count, so that I will only decrement and increment the count? Yeah, I guess so. Yeah, so let's subarray count, subarray number count map. Is there must be some good trick as well, but I'm so impatient, I just want to code. So let's code, okay? This will obviously work, I know that. So map, and then if norms I already exist, then if it already exists, if it does not exist, then I should say that the count is equal to 0. If it already exists, then I should say that the count should be equal to plus plus, right? Actually it should, I can just, this code I can just reduce it this way. The same code I can write it this way. Norms I will be equal to norms I or 0 plus 1, so if this is null, then it will be 0, and I'll do plus 1, so it is same as this. And yeah, so instead of adding, I will do this, and then how will I calculate the sum of this subarray then? So sub dot, I guess, how to calculate the size of a hash map? I guess how to calculate size of hash map. So if this is something like this, then how will I calculate that this is the count is 2? Maybe I should get the values then dot count, values dot length. So what is the formula for getting values? Object dot values, or what? Object dot keys, object that entries that keys. I don't know, I forgot. um, length of dictionary, JavaScript, object dot keys. Oh yeah, I was right. Object dot keys. So object dot keys of this one dot length, if it is equal to k. Okay, then it means that, so object dot keys, I think it should return the map, it should return an array of the keys. Oh, I should delete also. So this one must be minus minus. If it exists, then it will be minus minus. Why is it? Why? It is dodging. What the hell? Everything is not working. Expected is 15 and output is 10. Oh my god. Why am I rushing? I think that I'm rushing through everything, but nothing is working. So why is it not working? Like, I'm doing everything fine, right? I'm creating count and doing this 0 or plus 1. So this should create the map, and object dot keys dot length, if it is equal to k, then do this. So when I delete it, I'm deleting, decrementing the count. Oh, actually, I think I should not just decrement the count, but I should delete it as well. I cannot just keep 0, you know. I should delete it. So what I should do is, if it is 0, then I should just delete it from the map. But how can I delete it from the map? How can I delete it from the map? A is equal to, then a dot delete 1. How can I delete this key? So suppose if it becomes 0, you know, then I need to delete it. So actually what I can do here is, if it is equal to 0, then I need to delete it. So it's a dot delete. Does this work? I don't know how to delete. Delete. Oh, nice. Right? See, delete my city.city. So this should delete it. So it should delete Subarrays.nonce. What is happening here? I don't understand. How to delete? D. I'm thinking so quickly, but it doesn't mean that I should. I'm doing this right, right? I should delete it and I should check if it is equal to k, isn't it? So even in this case, this will be 9 3, and in this case it will be 9 and 1. Length will not be equal. In this case, it will be 9 1 1 1 1 2 1. You know, in this case it will be 3. The length will be 3. So 1 5 4 5 4 9 10. 5 4 9 10, 5 4 2, 5 4 9, 10 11, 4 2 9, 4 5 6, 9 6 15. Right? So why did this not come here? It should have. So 1 5 4 and 5 4 2. Right? It 5 should have been 1 should have been deleted and 2 should have been added. So 1 5 4 should be the solve count, right? In the beginning, 1's count 1, 5's count 1, 4's count 1. Right? 1 5 and 4 here. What will this operator do? I just want to know. So if A is equal to like B or 0, then what does this do? It's a bitwise. Oh, it is a bitwise OR operator. Oh shit! I don't want to do a bitwise OR. I want to do A or B. Okay, logical OR operator. I want to do that here, not that one. I think that is the problem. No, that is not the problem. What the hell? So I will just use test case and check, okay, what is the Subarray count map here. Subarray count map is 1 4 5. So yeah, that this is good. 1 4 and 5, right? And what is the Subarray count map here? So in the beginning, 1 4 5 1 1 1, and then 5 4 2. Oh, 1. What? It should be 5 4 2 only. Why is 1 not deleted here? I wanted to delete here. Why is this not deleted? Like, should I do something like this? -1. shit! I should do Subarray. Oh my god. Kill me. I should do norm Subarray start, not I. Why did I do I? And here it should be not I but Subarray end. That this is everything is very very funny here. Oh my god, I cannot believe myself. Turn off do not disturb mode. So yeah, time limit exceeded. But anyway, this is correct, right? Now, norm sub start minus minus. If it is 0, then deleting. Running sum. Or 0 0 plus 1. Okay, let's look at the solution then. Approach 1 sliding window. Instantiate our answer to variable 0, instantiate 0, initialize the 0, initialize the as map, start the window process. In the get the current number we are adding to our window, get its last occurrence. While the window still contains the current number, our window is too large, update the current sum, shrink our window by 1. Our window is good now, so add newly added element to our map, update the current sum. Instead of examining all possible Subarrays of size k, we can use a sliding window over norms to efficiently explore Subarrays that meet our constraints. This technique uses two pointers, begin and end, to present the indices of the current window or Subarray. Let's go over the high-level idea. In the sliding window approach, we typically start with an initial window containing just I'm streaming, right? Yeah. So in the sliding window approach, we typically start with an initial window containing just the first element. Then we try to expand our. I should have gotten a call, but I have not gotten a call. It's still okay. Then we typically start with an initial window containing just the first element. Then we try to expand our sliding window by incrementing end to cover more elements of norms. For each new element, norms end that we add to our window, there are two possible cases. Still satisfy the problem constraint, no longer satisfies. If the first case applies, then we continue expanding the window. If the second case applies, then we must adjust our window so that it satisfies the constraints again. This typically involves adjusting begin forward to shrink the window. Once adjusted, we can proceed with expanding the window to next element in norms. 999 and then 991. Now we can apply the above technique to our current. Because we are interested in the maximum sum, we also like to maintain the sum of our current window. Moreover, for each new element we add to our and to see if the following constraints are. So notice that our second constraint is slightly different from the constraint mentioned in the problem description. Does not exceed what? The length of the survey. Oh yeah. We only require the window to have a size less than or equal to k, not exactly of size k. What? Really? The length of the subarray is k. Yeah, it should be size k. This is because our we only require the. This is because our first few windows will naturally have a size less than k as we expand from the start. The key question is now to check if two constraints are followed. So to handle constraint, we can use a map to keep track of each element's occurrence, last occurrence index. Oh, each element's last occurrence index. We don't have to. If we just keep track of last occurrence index, then we don't have to keep count, right? We can just keep. Yeah, but if we keep track of each element's last occurrence index, then our map's size will be too large. But in my approach, the map size would just be size of k only, because we will be deleting and adding every time. This allows us to check if newly added element already exists in the current window. Yeah, this is a good way to keep track of last occurrence of each index. But even I don't like this approach very much, because we can just keep track of count. That way, yeah, we just know. Specifically, if the index of the last occurrence is greater than or equal to begin, then it is already in the window. To fix this, we have to shrink our window and adjust begin so that it includes the existing occurrence of norms and this means begin has to be greater than the last occurrence index. As we shrink our window to we also have to update the current sum of the window by subtracting the values of the excluded elements. We also have to update the current sum of the window by subtracting the values of the excluded elements. After this adjustment, for constraint to if the window size exceeds k, then we can simply increment begin until the size of our window returns to k. Encountered implementation. Yeah, this person has exactly done my way, and he has gotten upward of 1. But why am I having maximum time limit exceed error here, even if I'm doing the same thing? Should I use a map, not a dictionary? Because if I use map, then I don't have to create change into array every time. So let's try using a map then. New map, and then how to create a map. Wow, this is so intelligent. Very, very intelligent, ChatGPT. I just want one line. Can you please give me one line, baby? Oh, one line also. That it had already given me one line also. So it is a set norms I, map dot get norms I. Yeah, such intelligent human being, intelligent artificial human being. Yeah, anyway, so set norms I, this is the key and this is the value. So map dot get norms I, if it does not exist then it will be 0. Yeah, so the same thing, and here instead of this I can just say dot size. Dot size, yeah, it does not need a bracket, it does not need a bracket, but I'll also have to delete here. So map dot delete norm. Okay, so for deleting can I also do this in map? Is it the same thing? Instead of doing map dot get, can I just do map I? Does not retrieve the value because maps are not directly accessible this year. Okay, then I have to do dot get, then dot get. So if it is equal to 0, then I can just delete like this. Yeah, if it is equal to 0, then this will just get deleted like this, right? If this is equal to 0, then this will delete, but I also need to if it has some value dot get, if it has some value, then I will have to decrement something like this, then it will be -1. You know, right? Is this the way we delete it, decrement it? New count is equal to map dot get norm -1. Yeah, actually this is better. Anyway, does this work now? What happened? Oh, this is not map, this is the thing. So if it is there, then I will just set this. This is too much, I don't like it. What I can do is just get new count. New count is equal to, just like how they did it. New count will be map that count -1. So this will be my new count, but only if it exists, right? Oh no, it's okay, I will just do this way. There must be some better approach, but okay, and this is 2 barbers. So if I get it, if if this key exists here, if this key exists here, then I will have to if it exists here, then I will have to set, I will have to decrement it like this. So I decremented this value to -1. Okay, and if it is 0, then I deleted it. Yeah, map. Oh, anyway, 72 test case passed, which is good. So output expected is 3. 1 to 2. Why is expected 3? 2, 3. Oh, okay. All the elements of the subarray, the length of the subarray is k. It should be length of subarray should be k, right? Oh, but it is 2. So 1, 2. 2 plus 1 should be 3. Yeah, it should be 3. Oh, it because it is not this one, so here it should be this one. Okay, so it got submitted. So main thing is, what I was missing is map. Using of map, I think. Yeah, that was the main thing that I was missing. So there are the 3 things that I did wrong. One was not thinking about edge cases, because first of all I was trying to just use set. See, but when I use set, then this would just give me this would just delete 9. So I did not think about that, and only after looking at the wrong answer I thought, okay, and I came to know that I should use as map. That was my first mistake. And my second mistake was to use this variable. I was just using I for every variable, so I should be aware of that variable usage. I should just not copy and paste, because I was using I here, so I should be aware of that. And then my third mistake, which was the recent mistake, was to use map, to not use map. I was using dictionary, and for dictionary, to calculate, to find the length of the dictionary, for every sub array it would change into array, so it was giving me n times n time, because for every number I would just look at the size 9 and 9 and 9 and 1, so for every window it was converting every window to array again. So what is the point of using sliding window? So that is why using map helped here, because once I used map, I did not have to convert every window to an array to get the length, because map has a function dot size. I do not know how this maps background works. Maybe when map dot size, this data structure. So, but anyway, I cannot see that, okay, this is converting it into length, right? Like how I could explicitly see that dictionary, I had to convert it into length explicitly. I had to convert it into array before getting length. But this one has a function. I do not know how these functions dot size background in the background data structure works, but it looks like this is much more optimal. So yeah, and map is map.get, map.set. But I do not know, I do not like how verbose this is, I do not like it. I do not know how I can make it not so verbose. But yeah, that's what I know right now. So okay, thank you everyone, bye bye.